Hi class, welcome to a section 10-3. We're studying properties of logarithmic equations today. There are three different properties that we're going to be talking about. The first one is the product rule. So think add is the key here. Same thing when we had exponents. The power property of exponents was like x to the 5th times x to the 7th. That gives x to the 12th. You add when you multiply with common bases. A similar situation, when we have log base a of a product, x multiplied by y, we can expand this log by saying the log base a of x plus the log base a of y. So the log base stays the exact same, log base a, and then we just take the x plus the log base a of y. Let's look at this in another context. The log base 4 of 3x plus 1 multiplied by 2x. Being that this is a product right here, I can expand this log by keeping the same log base 4, and adding the 3x plus 1 and the 2x. So it's log base 4 of 3x plus 1 plus log base 4 of 2x. I can also think about this the other way around. Right now I see a plus sign right here with the same log base 4 and log base 4. Now I can keep that same log base and multiply 3x times 7. And that gives us log base 4 of 21x. So I could expand these logs and I could also contract them using the exact same property. Very similar with the quotient rule. Think with exponents, if I had x to the 7th divided by x squared, I subtract the exponents and I get x to the 5th. So think subtract when we're talking about quotients. So log base a of a quotient, x divided by y, so it's the log base a of the numerator, log base a of x, minus log base a of y. Keep the same log base and then subtract the x minus y. So right here, log base 4 of 7x over x minus 8. Keep log base 4 in both of them. Log base 4, log base 4. And that's the log base 4 of 7x. Subtract, because we're using the quotient rule, log base 4 of x minus 8. In a similar way, if I see subtraction right here with the same log base, I can combine these by dividing 3x and 7. So it's the log base 4 of the first one divided by the second one. So 3x divided by 7. We'll be doing some practice problems with those today. The last rule is the power rule. So this one has to deal with this exponent y. Whenever I see it raised to an exponent, I could always bring it out in front as a coefficient, and so now it's multiplied. So this power becomes a coefficient where I multiply, and that's where you see it right here. So this stays the same, log base a of x, log base a of x. The only thing that happened was the y moved from the exponent out in front to the coefficient. That's why you see it right there. So this log base 156 of 3 to the 4th, 4 at exponent can move out to the front as a coefficient. So now it's 4 times the log base 156 of 3. Same thing, if I see it out front here as a coefficient, at any time I want to, I can pull it up here as an exponent. And that's what happened right here. The log base 4 of 3x now raised to the third power. And then if you take 3x times 3x times 3x raised to the third, you get 27x cubed. So that's where that's coming from. We're going to use these rules to solve logarithmic equations in today's lesson. So here's what we got. I see log base 5 with a subtraction sign. I can use the quotient rule. So keep the same log base 5, put 2x in the numerator. Now instead of subtract, it's divided by x minus 3 in the denominator. Log base 5 of 2x over x minus 3. That equals the right side, log base 5 of 4. Now I see that they have the same log base 5. Log base 5, log base 5. That tells me, in yesterday's lesson you learned this, that 2x over x minus 3 equals 4. 2x over x minus 3 equals 4 over 1. How do you solve for x now? A proportion, you cross multiply. So we have 1 times 2x, which is 2x. 4 times x minus 3 is 4x minus 12. 4 times x minus 3. Use the distributive property, and you get 4x minus 12. Let's solve for this guy. Subtract 4x, and we get a negative 2x equals a negative 12. Divide both sides by a negative 2, and x equals a positive 6. There's the answer for problem letter A. Let's try problem letter B. Let's get you more familiar with this. Once again, you see log base 3 and log base 3 with a subtraction sign. When you see that subtraction sign with the same log base, you got to think quotient rule. So make a fraction out of it. Log base 3 of x, of this guy, divided by this one, x minus 2. That equals a log base 3 of 2. Now we see log base 3 and log base 3, so we can set this equal to this. X over x minus 2 is going to equal 2 over 1. Again, let's cross multiply now to solve for x. 1 times x is x. 2 times x minus 2, use the distributive property again, and you get 2x minus 4. Subtract 2x. Negative x equals a negative 4. Divide both sides by a negative 1. X now equals a positive 4. So there we have it there. Let's take a look at letter C. Notice how there's a difference. Now we see a plus sign, right? So we still have log base 6 and log base 6. So that's significant. We can combine these logs together. This time it's going to be using the product rule. When we see a plus sign, we can multiply. So it's the log base 6 of 2x minus 7 multiplied by 9. That equals the log base 6 of 1. Log base 6's are the same, are they not? So we can set this equal to 1. We'll distribute right away, and we're going to get 18x minus 63. That equals 1. Add 63. So we have 18x equals 64. And then we divide both sides by 18. 64 divided by 18 is a fraction that reduces to 32 over 9. X equals 32 ninths. There we have it for problem letter C. Why don't you guys pause the video, try letter D on your own. So for letter D, you saw that this was a plus sign with 2 log base 4's here. I can combine those together using the product rule. There we go. So it's the log base 4 of x multiplied by x minus 4. That equals the log base 4 of 12. All right, log base 4, log base 4. I can now set this equal to this. Math is great. X squared minus 4x when I distribute this. That equals 12. Let's get everything on one side now because I'm going to have to solve for x by factoring. X squared minus 4x minus 12 equals 0. Boom, boom, equals 0. We're going to have x and x minus 6 positive 2. So we're going to have two answers. X equals a positive 6 and x equals a negative 2. When we look at these class, it's always very important. It's a lot to remember, but you can never take the log base of a negative number. So to take the log base 4 of 6, that we can do. But to take the log base 4 of a negative number, and x is a negative 2, this, my friends, is extraneous. You can never take the log base of a negative number. So we have one solution, and that solution is x equals 6. So we've got to be very careful when we get these solutions that we check to see if they're extraneous. Let's take a look at letter E. This too hopefully is going to stand out to you the more practice you get with this. When you see something in front of a log, a coefficient, you're going to use the power rule and you're going to bring that up as a coefficient. Or as a exponent, sorry. So now it's the log base 2 of x plus 1 squared. That equals the log base 2 of a negative x plus 5. So this is significant because now we have log base 2 and log base 2, so I can set this equal to this. X plus 1 squared. X plus 1 times x plus 1 equals a negative x plus 5. Let's FOIL, shall we? We're going to get x squared plus 1x is plus 2x, and 1 times 1 is 1. That equals a negative x plus 5. Continuing to solve for x, let's add x over here and subtract 5 to get it over here. So we have a 0 on the right side now, and we have x squared plus 3x minus 4 equals a 0. Factor this beast. X multiplied by x, positive 4, negative 1. We get two solutions again. X equals a negative 4, x equals a positive 1. We should see if any of these are extraneous. Do we take the log base of a negative number? Well, if we put a negative 4 in there, what's a negative 4 plus 1? Negative 3. So to take the log base 2 of a negative 3 is extraneous. We cannot do that. So this one does not work. Our only answer is x equals 1. Continue on with letter F. Letter F combines two of our properties together. Here's the power property. 2 goes up here. And here's our quotient property. When we see that subtraction sign, it means that we could combine the logs using division. So we'll do this in 2 steps. It's the log base 3 of 4x raised to the second power. So we have that minus the log base 3 of x. That equals the log base 3 of 8. What a mouthful. Now, let's use the quotient property by saying, well, if it's log base 3 and log base 3, I could use that subtraction sign and change it to division of 4x squared divided by x. That equals 8. Oh, sorry, the log base 3 of 8. That's important. That equals the log base 3 of 8. Now I see log base 3 and log base 3, so I can set 4x squared, which 4x quantity squared is the same thing as 16x squared. 4x times 4x is 16x squared, divided by x. That equals 8 over 1. Cross multiply to solve for x. 8x equals 16x squared. 8x equals 16x squared. So now I'm going to subtract 8x, so I'll get a 0 over here, and 16x squared minus 8x equals that 0. Now I can take out a GCF of 8x, and I'm left with 2x minus 1, both of which equal 0. So 8x equals 0, and 2x minus 1 equals a 0. So I get x equaling 0 when I divide both sides by 8, and I get x to equal a positive 1/2, adding 1, dividing it by 2. Let's see if either of these are extraneous. If I put a 0 in or 1/2 in, 4 times 0, so this is good. Log base 3 of 0, that one's good. Looks like both of these solutions work. Sorry about that, class. I got to take that back. You cannot take the log base with anything for 0 either. That is undefined. It has to be a positive number. So obviously it can't be negative, nor can it be 0. It has to be a positive number. So the log base of anything positive. So we only have one solution for this one. It's x equals 1/2. Looking at this next one, again, we're going to combine several of our log properties. Here we have the log base g of 3x minus 2. This 5 is a coefficient, so we're going to bring it up here. So it's minus the log base g of 2 to the 5th. That equals, here is a coefficient. We're going to bring it up here. So it's going to be the log base g of x over 4 square root 2. Now that is going to be squared. Whew! We got a mess, don't we? Let's clean up this mess a little bit. We can use another property, being that we have a subtraction sign right here. We're subtracting their logs, and they have the same log base g. So I can condense this log equation to make the log base g of 3x minus 2 divided by 2 to the 5th. That equals the log base g of x over 4 square root 2, that quantity squared. Okay, now I have log base g and log base g, so let's set 3x minus 2 over 2 to the 5th, and 2 to the 5th power is the same thing as 32. Let's set that equaled to this, and x over 4 square root 2 squared is x over 4 square root 2 times itself. X times x is x squared. 4 square root 2 times 4 square root 2 is this. 4 square root 2 times 4 square root 2. 4 times 4 is 16. Square root 2 times square root 2 is 2, so we get 32. So it's x squared divided by 32. And that is what we get on the right side. When we take this squared, we get x squared divided by 32. What a crazy rigmarole, huh? All right, so now we're going to solve this equation. We already have common bases of 32 denominators, so all we need to do is set the numerators equal to each other. So 3x minus 2 equals x squared. 3x minus 2 equals x squared. Let's solve for x now by subtracting 3x and adding 2. We get a 0 on the left. That equals x squared minus 3x plus 2. Factor. X multiplied by x minus 2 minus 1. So we get two solutions for this one. X equals a positive 2 and x equals a positive 1. If you check both of these, both of them work, so we do indeed get two solutions for this one. Why don't you guys pause the video and try letter H on your own. Letter H, you should have had log base 7 of a negative 8x plus 2 equals the log base 7 of 4 raised to the 1/2 power. Because this 1/2, that was a coefficient, gets put up here. And then this 2 also gets put up here, so it's the log base 7 of x minus 4 raised to the 2nd power. Now that we have this should have been a plus sign. You're going to combine the two log base 7s using the product rule, so it's the log base 7 of a negative 8x plus 2 multiplied by 4 to the 1/2. 4 raised to the 1/2 power, you can put that in your calculator, it's the same thing as 2. That equals the log base 7 of x minus 4 squared. Now, as you've seen many times today, log base 7, I can set 2 times a negative 8x plus 2 equal to x minus 4 quantity squared, which is x minus 4 times itself. Let's solve for x, a negative 16x plus 4, that equals x squared minus 8x plus 16 when you FOIL that. Let's get everything off to the right side by adding 16x and subtracting 4. You get a 0 on the left. That equals x squared. Add 16x to get 8x. Subtracting 4 to get 12. Factor this guy. And you got x multiplied by x and a positive 6 and a positive 2. So when you did this on your own, hopefully you got x equals a negative 6 and x equals a negative 2. What does that mean, class? When we check our work, we can take the log base of a negative number. So if you put negative 6 and negative 2 into this one right here, you would end up with both of them being a log base of a negative number. So this one does not work, this one does not work. For this one, there is no solution. This one has no solution. And there's the answer for problem letter H. Okay, last two, I and J, and they are a little bit tricky. So pay very close attention here. We're going to use the product rule, which means that I can take the log base 4 of x multiplied by x minus 6. That equals 2. Now, we cannot set this equal to this. We cannot do that because there is no log base 4 there. If there was, then yes, we could set these equal to each other. But there is no log base 4 written there. So we cannot set x times quantity x minus 6 equal to 2. What we can do is whenever we get stuck, we could change the form. This, my friends, is in logarithmic form. Let's change it to exponential form. So to change it to exponential form, we're going to take the same base 4, raise it to the number on the right, 4 squared equals this, x squared minus 6x. Now that it's an exponential form, we are unstuck and we can now solve for x. Subtract 16 from both sides because 4 squared is 16. So 0 equals x squared minus 6x minus 16. Now we can factor this guy down. X times x minus 8 and a plus 2. And we get a 0. So x equals 8 and x equals a negative 2. Check to see if we get a negative log base. Log base 4 of x. So a log base 4 of a negative 2 is extraneous. Can't have that. X equals 8 is our only answer. Whew! Let's try letter J on our own. Pause the video. Try this one. So here we're going to use the quotient property. So it's the log base 2 of 4x divided by x minus 4. That equals a 3. Now you can set 4x over x minus 4 equal to 3. I hope you guys all saw that. So we got to change the form. Whenever you get stuck, try to change the form. Logarithmic to exponential. The same base, 2, raised to the number on the right, which is 3. That equals 4x over x minus 4. I hope you did that. So 2 cubed is the same thing as 8. So 8 over 1 equals that. Cross multiply. 8x minus 32 equals 4x. Subtract 4x. Add 32. And we get 4x equaling 32. Divide both sides by 4. And x equals 8. There's our lesson on different properties of logarithmic equations. Let me know if you have any questions on that when you get to class tomorrow.